Awesome. Okay, for input, we have some length of the discipline words today. Okay, so go ahead and do your L/D for length of the discipline and draw your icon. Words that we need to know. The first one is a system of linear equations. A system of linear equations. This just means two or more linear equations that are together. Two or more linear equations together. That's called a system of linear equations. So there's more than one on the graph. Okay? The second one is solution of the system. So when you have these two lines together, what do they mean? Okay? This is any ordered pair. And we know an ordered pair is x comma y, right? Ordered pair. That makes all equations true. Any ordered pair that makes all equations true. Right below here, I'm going to show you the different types of solutions that you can have by graphing. So we're going to draw a little bit. Let's use green. All right. So we're going to call this graphing, and I'm going to show you a number of solutions. I'm going to show you 3 different types. Graphing, number of solutions. Okay? The first type looks like this. Go ahead and just draw 3 of these right now, and then I'll show you them at the end. Okay? Go ahead and draw 3 small graphs. Draw 3 small graphs. The first one looks like this. Draw a line across. And then draw a line intersecting the other line. That's your first type. This type has different slopes with one solution. The slopes are different. The rise over run is different, or else they'd be parallel. And they only have one solution, which is where they cross right here. That's their one solution. So go ahead and write that down. Different slopes. One solution. Different slopes, one solution. Then on your next graph, you're going to have lines that are parallel to each other. Lines that are parallel to each other. These lines, do they have the same slope? Yes. Do they have the same y-intercept? No, they don't intersect at the same point on the y-axis. And they have no solution. They don't have a point that they meet. Okay? So you're going to write 3 things. Same slope. Different y-intercept. And no solution. Same slope, different y-intercept, and no solution. They can't have a solution if they don't touch at a point. They only touch at one point, that's one solution. The last one you're going to draw a line. And you're going to draw another line right on top of that line. These lines are one right on top of the other. Well, they have the same slope because they're the same line. So I have same slope. I have the same y-intercept because they cross at the same point. But how many solutions do I have if they're one line on top of the other? I have infinitely many solutions. So you're going to write three things. Same slope, same y-intercept, and infinitely, like infinity, right? Infinitely many solutions. I'm going to give you a ladybug, this one keeps glitching. So basically, you're going to be given equations. When you looked on your pre-test yesterday, they had equations and they said solve the solution by graphing. You would look at those equations and say, do both of these equations have the same slope? And you use process of elimination. If they have the same slope, then you know it's going to look like one of these two. And then you go, do they have the same y-intercept? If they do, it's a graph like this. If they don't, nope, it's a graph like this. So this is the three types of graphs. We just have to be able to identify them. That's why we needed to look at earlier slope-intercept form. Okay, so keep these graphs in mind. So I'm going to give you the steps on how to do this. I'm going to turn my paper over. And here are the steps into graphing those solutions. Okay? Step number 1. Make sure that the problem is in slope-intercept form. That'll help you graph. See what the graph is like. Number 2, you're going to graph the y-intercept and the slope. Once you graph the two equations, you can tell me whether it is a one solution problem, whether it's a many solution problem, or no solution problem. Those are the three types of answers. Okay? It's only 2 steps. All you have to do is graph it, and then you can identify. So I'm gonna include step number 3. I'm gonna say identify the graph. So you're gonna let me know, is it infinitely many solutions? Is it one solution or no solution? And why don't we write that down? Identify the graph. Is it no solution? Is it infinitely many solutions? Or is it one solution? That way you can go back to your notes and say, which one am I going to use for my answer? So that's one method, the graphing method. You graph it, tell me how it is. The second method is called the substitution method. Let's see, let's make that one a different color on here. We'll keep it the same. Substitution method. Okay, in the substitution method, you do the following. You replace one variable, x or y, with an equivalent, meaning equal, expression, algebraic, containing, definition's a little lengthy, the other variable. Replace one variable with an equivalent expression containing the other variable. In fancy words, they give you x and y. You take what y is, plug it into the other equation, and solve. So you're taking the solution and plugging it into another equation. So let's write the steps. Step number 1, you're going to solve one equation. So they give you two. You're going to solve one equation for one variable. I always just like to solve for y because then it's in slope-intercept form and it's easy. Write that step down. Number 2, I'm going to substitute that solution into the other equation. I'm going to substitute that solution into the other equation. Number 3, I'm going to solve for the other variable. And number 4, I'm going to write both of my answers as an ordered pair. I want to make sure everyone has those 4 steps written down. Solve one equation for one variable. Substitute that solution into the other equation. Solve for the other variable and write as an ordered pair. I want you to turn to the person next to you and I want you to read those 4 steps to them. Ready, go. Step 1. What's step 1, Megan?
Solve one equation for one variable.
Very good. Give us a move for that. Give us a hand motion. Help us remember. Solve one equation for one variable. Anybody?
One equation for one variable.
Get everyone, do 1 twice. Ready, go. Solve one equation for one variable. What's step number 2? Becky, what's step number 2?
Substitute that solution for the other solution.
Good. Substitute that solution into the other equation. How can we use the hand motion for that?
Oh no.
Why don't we take 2 equations? Everyone take 2 equations, like you're an Egyptian. All right? Substitute that equation into the other equation. Slap it. Boom. Substitute that equation into the other equation. Go back to step number 1. Solve one equation for one variable. Then you do what? Substitute that solution into the other equation. What's step number 3? Nicole, what's step number 3?
Solve for the other variable.
Solve for the other variable. What are we going to do to solve for the other variable? Let's make an equal sign like we're solving. Solve for the other variable. Everyone say it. Solve for the other variable. And then your last step is to write it as an ordered pair, which is x comma y. So we're going to pretend we're mimes. Write as an ordered pair. Ready? Let's say all the steps with the hand motions. Ready? Number 1, go. Oh, that was weak. Let's try again. Ready? Say it louder. Go.
Solve one equation for one variable.
Step number 2. Step number 3. Step number 4. Very good. You're not going to forget it now. You have hand motions. All right, so I'm going to move into modeling. I'm going to show you how to solve these types of problems. So this is example 1. And it says solve the system of equations by graphing. So they're telling me I'm not using substitution method, I'm using graphing. Solve the system. Please write the directions down, it's important for your homework. By graphing. Solve the system by graphing. Alright, so let's look at letter A here in example 1. They're going to give me 2 equations. Here's my first one. Y equals 2x minus 3. Okay. My second equation they give me is y equals x minus 1. So I'm going to solve this by graphing. What do I have to do? Draw a graph. So I'm going to draw a graph. I'm going to make mine about 5 squares. Everyone please draw a graph. Okay. So let's graph the first equation. Let me label my graph. This is 1, 2, 3, 4. You guys can please label your graph up to 4. -1, -2, -3, -4. -1, -2, -3, -4. And that's positive. -1, -2, -3, -4. Label your graph up to 4. So now that I have my graph, I'm going to look at the first equation. Are they both in slope-intercept form? Yup. So do I need to change them at all? No. So let's look at the first equation. Can everyone please highlight or circle the y-intercept on the first one, which is -3. That means that my first graph crosses at -3. So I'm going to go down, 1, 2, 3, boom. There it is, right here. Please draw the dot. Now, what's the slope? What's the slope? What's my rise over run, guys?
2 over.
2 over 1. So I'm going to go up 2 to the right 1. I'm going to go up 2 to the right 1. Up 2 to the right 1. I'm going to put a dot every time. Up 2 to the right 1. And then I'm going to connect dots. I use the ruler to draw my line. So we just check the first equation. We need to now graph the second one. What is the y-intercept of the second equation?
-1.
-1. Good. So let's go put a dot on -1. Start at 0, go down 1. Boom, there's my dot. Now, what's my slope? What's that invisible number in front of x?
1.
1. So it's rise up 1 to the right 1. So I'm going to count from there. Up 1 to the right 1, put a dot. Up 1 to the right 1, oh, put a dot. Up 1 to the right 1, put a dot. Up 1 to the right 1, put a dot. Just put a couple so you can see where your line's going to be. And then I'm going to draw my line. Now looking back at our notes, remember we drew 3 types of graphs. Is this going to be a graph that has infinitely many solutions? No, they're not one line on top of the other. Is it going to be a graph with no solution? No, because they're not variable. So how many solutions does it have? 1 solution. Now that solution we have to identify. It's where both lines cross each other. Do you see where that is? Right here? Draw a circle around where you see where that is. That's where the graphs meet. So we need to write the ordered pair for that one solution. So what's the pair? Let's see. It's +2, up 1. So the solution is 2, 1. That's it. That's your answer. So again, just to walk through that problem, I graph the first one, graph the second one, and then my answer is the point where they meet. Make sense? Cool. Let's try letter B. Y equals 4x minus 2. My second equation is y equals -3x plus 5. Solve by graphing. So I'm going to do the same process. I'm going to draw my graph. I'm going to do about 6 squares. You can choose if you would like. Go ahead and draw your graph. I'm going to label mine by 6, okay? So I'm going to go positive 1, 2, do it with me, 3, 4, 5, 6. You're going to go up, positive 1, 2, 3, 4, 5, 6. I'm going to go down the elevator, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And to the left, negative 1, negative 2, negative 3, negative 4, negative 5. The part about graphing that most people don't like is it's very tedious to write all those numbers down. I totally get it. But once you do that, it's cake. Okay? So now that my graph goes up to 6, let's look at that first equation. What's my y-intercept? Negative 2. So I'm going to go look for, starting at 0, put your pencil on 0, go down 2 and put a dot. Now, what's my slope? The number in front of x. 4. 4 as a fraction is 4 over 1, right? So I'm going to go up 4, positive 4, to the right 1. So let's count. Put your pencil on the 2 that you're at, where the dot is, and count up 4. 1, 2, 3, 4. Go to the right 1 and put a dot. Do it again from that dot. Go up 4. 1, 2, 3, 4. To the right 1. Okay. Then I'm going to draw my line. Awesome, we graphed the first one. Check. Now I just need to graph the second equation. My slope is 3 and my y-intercept is at positive 5. My slope is negative 3. Negative 3 as a fraction is negative 3 over 1. So let's find the slope first. It says my y-intercept is a positive 5. So I'll start from 0. I'll go up 1, 2, 3, 4, 5, put a dot. Found the y-intercept. From 0, count up 5. All right, now let's do the slope. Down 3 to the right or left 1?
Right.
Right is positive. Negative 3 over 1. Down 3 to the right 1. We understand? Okay, so I'm going to go down 3. 1, 2, 3 to the right 1. Oh. Down 1, 2, 3 to the right 1. Down 1, 2, 3 to the right 1. You just keep counting over and over again. Down 3 over 1. Down 3 over 1. And then I'm going to connect. This looks the same as the last graph. There's only one solution, one point where they meet. So let's see. Let's identify what that point is. That point looks like it is to the 1, x, 1, y, 2. 1, comma, 2. So you're just identifying the point where they cross. Okay? Next one. Sorry, doing examples because there's a lot. I have 3x minus 3y equals 9. Uh-oh, it's not the slope intercept. And then I have y equals x minus 3. Well, I'm kind of stuck here because the first thing I need to do is get this first equation in the slope intercept form. So I'm going to draw a line here so I can solve it. I have 3x minus 3y equals 9. In slope intercept form, I want to get y by itself. So I'm going to subtract 3x from both sides. Do it with me, please. Positive 3x and negative 3x cancel. I'm left with negative 3y equals negative 3x plus 9. Now remember, I put the x in front of it because slope-intercept form, x needs to be in front. So now I'm going to divide both sides by -3 so that I can isolate my variable. 3's cancel out and I'm left with y equals -3 divided by -3 is a +1, so x minus 9 divided by -3, 3. So that's x minus 3. So now this equation's good. I changed it. Now, are these equations, do they look a little similar? They look exactly the same, right? So, you're going to graph, and it's going to be super easy. You're going to laugh, because you really don't need to graph that much. Okay? So, what's my y-intercept of both these equations? Everybody? -3, all right? So, I would be down 1, 2, 3. Labeling my graph. And now, what's my slope? What's the number in front of that x? What's the invisible number? 1. How do I write that as a fraction? 1 over 1. So rise over run, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, over and over again. And that's my line. Is my line going to be the same if I graph the second equation? So do I need to do it?
Nope.
So what's my answer?
Infinitely
Infinitely many solutions. That's your answer. Infinitely many solutions. Because both lines are one right on top of the other. So those ones are going to be really easy when you see those on your homework. The part that's going to be harder is just you turning it into slope-intercept form to see if it's going to be infinitely many solutions. Other than that, you don't have to do much work. Last example on graphing. I'm going to give you one more example on graphing, then we're going to move to substitution. I have y equals -x plus 2. And then they give me, of course, because they want to make it difficult, 3x plus 3y equals 12. So before I even think to start graphing, what do I need to do first? Turn the second equation into slope-intercept form. You're not going to have to do that with substitution. You have to do slope-intercept form because we're graphing. Okay? So let me take this equation right here. And let's change it, 3x plus 3y equals 12, into slope-intercept form, which is y equals mx plus b, right? Get y by itself. So to get y by itself, I'm going to subtract 3x from both sides. Please do that with me. Positive 3x and negative 3x cancel. So on this side, I'm left with 3y equals, remember the x comes first, and this negative is attached to that sign, minus 3x and a positive 12. Stay with me, I know, stay with me. Now I'm going to divide both sides by 3 to get y by itself. 3's cancel. I'm left with y equals -3 divided by 3 is up -1, right? So it's going to be -1x, which will end up being -x. And then 12 divided by 3 is +4. So y equals -x plus 4. That 1's invisible. We don't need it there. Easy now. Okay? Now it's a piece of cake. I have this equation right here and this equation right here that I need to graph. So let's go ahead and draw our graph. Okay, my graph's I'm gonna go up about 4 is fine with me. Go ahead and set your graph to about 4. Please draw the graph with me, everybody. Almost there. The graphing is the tedious part. All right. My first equation right here. Negative x plus 2. What's my y-intercept?
2.
Positive 2. Awesome. So let's put a dot on positive 2 starting from 0. Awesome. Now what's my slope? Negative 1 over 1, right? So that's down 1 to the right 1. Down meaning negative to the right positive. So let's go from that dot. Down 1 to the right 1. Down 1 to the right 1. And it's going to keep going. Do a couple and connect the dots. Go ahead and do that. Perfect. We've graphed the first one. All we have left to do is graph the second one. Let's look at the second equation. What's my y-intercept? Positive 4. Is my slope the same?
Yes.
Yes. So put that dot on positive 4. I have a negative in front of the x. That's negative invisible 1. Negative 1 over 1. So down 1 to the right 1. 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 I'm not doing this for me, so take notes. And I draw the line. Now that I know that my lines look like this, go back to those three things. Is it infinitely many solutions? No, it can't be. Is there one solution where both lines cross each other? No, it can't be. So my answer is no solution. Everybody get up and stretch for a second. Move around, touch your toes. 7th inning stretch for a second. And 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Everyone, take your right hand. Take your right hand. Grab your ear. Take your left hand. Grab your nose. Now switch. Oh, now switch. Oh, now switch. Now switch. Oh, gave yourself a little brain break. It's harder than you think. All right. Let's go to example 2, which is solving by substitution. Example 2. Solve the system using substitution. Come on, guys, you're smart. You can write it. Take notes. When you get to high school, your teacher's not going to make you take notes, and you're going to be stuck. So you got to get good habits now. Solve the system using substitution. Now going back to the substitution method, we know that we solve one equation with one variable, and then we substitute that into the other solution. And then we solve for the other variable, and then we write as an ordered pair. 4 steps, okay? You have that in your notes. You can look back at it. It's right there. And you know they have motions because we just did the bodily kinesthetic. All right? Here's letter A. They're going to give me y equals negative 4x plus 8. And then they're going to give me y equals x plus 7. Well, solve one equation for one variable. Well, they already solved it for me. I know what y is. So I don't need to do that. Okay. Substitute one of the solutions into the other solution. When you have 2 equations that are already solved for you, they already know. They say this is what y equals, and this is what y equals. When you have 2 equations like that, you need to put them side by side next to each other. right? So, for example, I'm going to take y, this first one. How am I going to show you this? I'm going to take this equation. So I have y equals negative 4x plus 8. Well, I want to solve for x, so can I plug something in for y? If you look at this equation, it's telling me that y is x plus 7. Okay, so it's telling me right here, x plus 7 is y. So I'm going to substitute that in for this y over here. I'm substituting this in for that. So then, if I substitute x plus 7 for y, and the rest of my equation is negative 4x plus 8. I'm substituting y in. So basically, you just want to end an equation with solely your x's. Not your ex-boyfriend or girlfriend. Just the x on here. Okay? So, now we need to get all the variables on one side. So I'm going to add 4x to both sides. Now you're just going to solve it. All right? X plus 4x is 5x. There's a 1 in front of that. 5x plus 7 equals negative 4x and positive 4x cancel. I'm left with 8 on that side. Next thing I need to do is isolate the variable, so I'm going to subtract 7 from both sides. Those cancel, so I'm left with 5x equals 1. And lastly, divide by 5 on both sides to isolate the variable. X equals 1/5. Well, I have a number for x, 1/5, but I don't have a number for y. So this is just the first part. I have x, now I need to find y. So I'm going to pick one of these equations and plug x into it. I'm going to pick the easiest one. Y equals x plus 7. So I'm going to plug that in. 1/5, which is what I got. I'm going to plug that in for x. Y equals 1/5 plus 7. So y equals 7 1/5. 7 plus 1/5. That's my second part. Now, last part to my equation. We already solved one equation for one variable. We substituted that solution into the other one, which is what we did here. We solved for the other variable. We got x. Last part, write as an ordered pair. X comma y. So what's my x? 1/5. What's my y? 7 1/5. Done. That's your answer. The ordered pair is your answer. Substitute one in for the other, find x. Substitute it back, find y. Write as an ordered pair. Pencil up if you have that, so I can move on to example B. Okay. Example B. Come on, everyone. I know it's hard. You gotta write. You gotta do it. Math is practice. Once it's practice and it's in your head, it'll be easy. Y equals x minus 7. 2x plus y equals 8. Those are the two equations they give you. You always want to take the equation that is solved for you. Y is solved for me in the first one. The second one, I don't know what either variable is. So I'm going to take that second equation, 2x plus y equals 8. And I'm going to substitute the second equation in for y. Please draw that so you know when you get home. So I'm solving the second equation for y. So now when I plug it in, I have 2x plus, what's y? Y is x minus 7 plus x minus 7 equals 8. So again, wait, what happened, Miss Graham? Here's y, it's already solved for me. Here's y in that second equation. Here's y, I plugged it in. Y is x minus 7. Now solve it out. 2x plus x minus 7 equals 8. 2x plus x, there's like an invisible 1 there, so it's 3x minus 7 equals 8. Write it down. And then, to isolate the variable, I'm going to add 7 to both sides. Negative 7 and positive 7 cancel. I'm left with 3x equals 8 plus 7, 15. Almost there. Isolate the variable by dividing by 3 on both sides. 3's cancel. X equals 5. Well, that's the first part. First part's the hardest part. Then you got to plug it back in to get y. So I have x minus 5 here. I'm going to go up here. Y equals x minus 7. I'm going to take the easiest equation and plug x. I'm going to plug x into this equation. So I have y equals x, which is 5, minus 7. Y equals 5 minus 7 is negative 2. I found x and I found y. Last part, write in an ordered pair, which is x comma y. 5 comma negative 2. X comma y is your answer. So you're substituting it in. Alright, example C. 3x plus y. Bear with me because I want to show you every single type of problem so you have one to refer back to when you do your homework. There's a method to the madness. You must do it. I know. 3x plus y equals 10. Second equation is y equals negative 3x plus 4. Which equation is already solved for me? The first one or the second one? Second one, right? Because it says y equals. It's already solved for me. So I'm going to take the first equation then, since the second one is already solved for me, and plug y into that equation. Again, what am I doing? I'm taking y and plugging that in. So I have 3x plus y equals negative 3x plus 4 equals 10. So again, what did I do? I took what y equals, plugged it in for y. Use your highlighters. So you know where the numbers come from. Alright, so then I have 3x minus 3x plus 4 equals 10. Because a positive and negative side next to each other, I know is a negative. Wait a minute. 3x minus 3x. Is 3x minus 3x 0? Huh. So 3x minus 3x cancel. So I'm left with 4 equals 10. Does 4 equal 10? No. So guess what? On that type of problem, you can stop. And what's your answer? No solution. There is no ordered pair solution. I can't go any further because 4 doesn't equal 10. You can stop right there. You like these kind of problems, right? I'm going to give you one more example before we go to lunch. And when we come back from lunch, we'll check for understanding, do guide independent practice, and then move on. Okay? Letter D, last one. 4x plus 2y equals 8. Second equation they give me is y equals negative 2x plus 4. Which equation's already solved for me? Second one. All right, so that's the one I'm going to plug in. So I'm going to take the first equation. 4x plus 2y equals 8. Now, we just said this was already solved for me. Y equals 2x plus 4. And I'm going to plug that in for y. So when I plug that in, I get 4x plus 2 times the quantity. Now I need to plug in y. Y is negative 2x plus 4. Negative 2x plus 4 equals 8. So again, this right here is y. Write it down, please. Last one, let's go. Doing a good job. We're almost there. All right. We're going to have to distribute. So 4x plus, let's see, 2 times negative 2x is going to be a negative 4x. And 2 times 4 is a positive 8. Positive, negative sign next to each other right here is going to be a negative. So 4x minus 4x plus 8 equals 8. Oh, this looks like the other problem, but not quite. Is 4x take away minus 4x 0? Okay, so they cancel out. That's not going to work. But wait a minute, I'm left with 8 equals 8. Does 8 equal 8? Yes. So it's not no solution. What do you think it is? Infinitely many solutions. Infinitely many solutions. Thank you, Alex. So basically, when you